Hey everyone, and welcome back to the GCSE Maths Series. Today we're going to be looking at exam style questions for our scatter graphs. Okay, so looking at the first question, it says Gary recorded how many goals 10 football teams scored. He also recorded how many goals they conceded. The information is shown on the scatter graph. Remember, scatter graphs are supposed to show us a relationship between two different factors or two different events or two different variables. So in this case, it's about goals scored versus goals conceded. And I assume that he's supposed to test uh, if there's a correlation between the number of goals a team scores or the number of goals they concede. So basically trying to see who's the best team and if they that's what he's trying to show. So what type of correlation does the scatter graph show? So, okay, before we attempt a question like this, remember we always must draw our line of best fit. And yeah, so it's going to be something like this. That goes through as many points as possible. I know there's some outliers, but that's normal. So you want to leave as much space from going down to points like this to points going up like this. So what type of correlation does this show? Okay, so it shows a negative correlation if you remember from our graphs. And if you think about what this means, it means that as the number of goals a team scores increases, the more they score, the less they concede, which is, if you were to think about it, makes a lot of sense. So say if you're one of the best teams in the league like Man City or Liverpool, you were scoring more goals and conceding less because you were just a better team. You were winning more games, so more goals scored, less goals conceded. And if you're conceding more goals, like a relegation team, then you would concede more and score less. Which is, if you look at points on the graph here, say like someone who conceded 52 goals, they only scored 25. Whereas a team up here, they scored 66 goals but only conceded 21. Hence, that shows a negative correlation that as one increases, one decreases. And that's all the scatter graph is trying to show. So, another team has scored 44 goals. Estimate the number of goals the team has conceded. Okay, this is again linear interpolation. Remember, we looked at this in the revision video. It's basically something that's not been plotted, but it's within our data, within our range, sorry. So we don't need to extend our graph. So we draw a line from goal scored at 44. So around here. And then we draw our line coming down like this. And we can say that the number of goals this team has conceded is 42. And this is based on our scatter graph and our line of best fit. In questions like this, they'll usually give you a range because obviously not everyone's line of best fit is going to be the most similar. But it's a question that we should be getting right. Okay, now looking at question 4, it tells us the scatter graph shows information about test scores of some students in maths and English. The table shows two scores of two more students, and the first student got 70 in maths and 64 in English, and 84 in maths and 68 in English. Show this information on the scatter graph. So before we do this, we have to see how much does each increment worth, and an increment is one tiny little square in the graph. So if we're looking at, let's put English score first. So the first student got 64, but the 10 squares is worth 20.20 scores. Let's call that scores. And then, which means that each one is going to be worth 2. So 64 is going to be here, if you were to plot that. And 70 is going to be up here. So plotting that, we just meet in the middle. Plot that there. Then second student, 84. 84 is going to be here. Oh wait, no. 84, that's wrong. We're going to plot the English scores first. 68 is going to be around here. And then 84 is going to be somewhere up here, like that. And there you go. There are 2 points plotted within the graph. It says another student scored 56 on the maths test. Use the scatter graph to estimate this student's score on the English test. So again, we're going to have to use our line of best fit and draw a line like this. So now we can use linear interpolation. Another student scored 56 on the maths test, so we draw a line for going from 56, so 50 is here, count 2, 52, 54, 56 is here. So drawing a line across, we go here. We draw a line going like that, using a ruler obviously, and I'm working on an iPad here, so it's a bit difficult, but you guys will use a ruler. Okay, and we can see that this is clearly 44, and we estimate that this student got 44 in her English test, or on their English test. Okay, this question is a bit different, but it says Wayne has data about the number of goals 10 football players have scored and the number of games that they had played. He was asked to display the data on a scatter graph. Here is his answer. Wayne has plotted the points accurately. Write down 2 things which are wrong with his answer. Okay, so the first thing that I've noticed is that his axis for goals scored is not linear, and linear means linear means equal distances. If you look at his y-axis, it goes up by 10, goes up by 5, goes up by 5, goes up by 5, goes up by 5, right? But here, the first one goes up by 10, which means it's not linear. So the first thing you can write, y-axis scale is non-linear. The line of best fit in this case, we can see that this is also wrong with his answer, because it does not really represent the data. It doesn't really show the true representation. So the data follows a trend more suited to a line like this, where you can kind of see how sharp the increase is, whereas this one is more relaxed and it's more not showing, it's more of a steady rise. This shows as soon as the games start getting more and more, the number of goals scored just shoots up like this. So the line of best fit does not fit the correlation. Okay, moving on to the last question today. I think, yep, last question today. The average daytime temperature for 10 days is recorded. A shop also records its ice cream sales for each of the 10 days. And the scatter graph shows the information. So ice cream sales on the y-axis, average temperature on the x-axis. What type of correlation does the graph show? So obviously drawing our line of best fit, it's going to look something like this. And obviously my line's not entirely straight, but you're going to use a ruler in your exam and make sure this line is perfectly straight, trying to show the data off as much as possible. So what type of correlation does this scatter graph show? It shows a positive. It shows that as one increases, the other one increases. And the best way to do this is pick one point here and pick another point here and see what the average temperature looks like, and see that as one increases, the other one also increases. So let me just rub these lines out now. Okay. Looking at part B, it says on the 11th day, the temperature was 12 degrees. Estimate the ice cream sales on the 11th day. So it says it mentions that it was 12 degrees. So we look at our average temperature and we go to 12, and we see that 5 degrees Celsius is equal to 10 squares, which means that 1 square is equal to 0.5 degrees Celsius. So if we're to go to 12 degrees, remember this is going to go, first square is going to mean 10.5, second square is going to mean 11, then 11.5, and then we're at 12 here. So we then draw our line going upwards like so, and we draw it going across like so, and we work out, okay, so it's the one line above the intersection, so this is going to be 125 because that's the midpoint of 100 and 150. If you remember, the formula for midpoint is a plus b over 2, so 150 plus 100 over 2 is going to be 250 divided by 2, which is equal to 125. That's how I got that. Each square is worth 5 because 5 squares takes you to from 100 to 125. So the ice cream sales was 130, like that. Okay, the shop's manager wants to use a scatter graph to predict the ice cream sales for a day with an average temperature. Comment on the reliability of this prediction. So remember when I taught you guys about linear extrapolation? This is when we can predict something outside of our data range. This question is not to do with that, but it would be a similar sort of concept. This is why I brought it up, that if it was there. So our range of data, remember, if you look, the earliest temperature that we've plotted is for about 7 degrees, yeah? If you can see, this is 7 degrees Celsius, and this is where the first point is plotted. Our 2 degrees Celsius is outside of that. So it is extrapolation, actually. So to predict 2 degrees, which is outside of here, which is about here, right? We would then be predicting outside of the range of data. So we can say that it would not be a reliable prediction as 2 degrees Celsius is outside our range of data. Okay, that's going to conclude today's exam style series. I hope you guys enjoyed. As always, please like, comment, and subscribe, and I'll catch you guys in the next one. Peace.